Somewhere, in the vast expanse of the cosmos, among the billions of galaxies, stars, and planets, lies our little home, Earth. But how did we get here? How did it all begin? Today, we will travel back in time, long before the existence of Earth, the stars, or even the first light, to witness the birth of the universe. Join us on an epic journey to the moment of the Big Bang, where everything began. Discover how, from an infinitesimally small point, everything we know came into being. About 13.8 billion years ago, the universe was compacted into a singularity. And then, the unimaginable happened. That point exploded into existence. In fractions of a second, the universe expanded exponentially, creating space, time, matter, and energy. As it cooled, the first subatomic particles formed the simple atoms. The universe was still a hot, dense soup, far from the complex structures of today. But this was just the beginning of our cosmic story. Imagine the universe as an infinitesimally small point, containing all matter, energy, space, and time. Then, suddenly, the Big Bang. But it was not an explosion in the traditional sense. It was the beginning of the expansion of space itself. In the first moments, the universe was incredibly hot and dense. In this primordial cauldron, a crucial event known as cosmic inflation occurred. In a fraction of a second, the universe expanded faster than the speed of light, growing from smaller than an atom to encompass the vast cosmos we begin to recognize. The extreme temperatures of the early universe allowed elemental particles to form. Quarks and leptons, the building blocks of matter, emerged from nothing, dancing in the intense heat. As the universe continued to expand and cool, these elemental particles began to combine in complex ways. Quarks clustered together to form protons and neutrons. And, within minutes, the universe had cooled enough for protons and neutrons to combine, forming the first atomic nuclei, marking the beginning of primordial nucleosynthesis. This was the raw material of the universe: hydrogen, helium, and traces of lighter elements. The matter that would eventually give rise to stars, planets, and, of course, life. And it all started in the first fractions of a second after the Big Bang, in a process that challenged and redefines our understanding of everything that exists. After the initial fizzling of the Big Bang, the universe entered a long phase known as the Dark Ages. Without stars or galaxies, it was an unexplored and silent cosmos, waiting to awaken. But that silence would not last forever. As clouds of gas began to collide and condense under their own gravity, the first stars were born, illuminating the universe with their light. These stars were not alone. They gathered, forming the first galaxies, immense islands of stars dancing together across the cosmos, each containing billions of suns. In an eternal cycle of creation and destruction, stars were born and died. Supernovas spread the essential elements for life across the universe, while new stars and planets began to form from the remnants. At the heart of every star, an epic battle unfolds between the force of gravity, which seeks to compress the star, and nuclear energy, which expands it. This delicate dance determines the fate of each star in the cosmos. For most, life begins in the nebula, where clouds of gas and dust collapse under their own gravity, igniting nuclear fusion. The life of a star is a tale of transformation. Stars like our sun shine for billions of years, fusing hydrogen into helium. But what happens when the hydrogen runs out? Massive stars expand to become red giants, while smaller stars become white dwarfs, slowly fading away. The dramatic end of a massive star is a supernova, an explosion so bright that, for a brief moment, it can outshine an entire galaxy. This cataclysmic event spreads heavy elements across the cosmos, elements that are the building blocks of life. What remains can be an incredibly dense neutron star, or, if the star is sufficiently massive, a black hole. But even in death, stars are creative. The dust and gases released by supernovas and red giants fuel the formation of new stars, planets, and possibly life. This cycle of birth, life, and stellar death is fundamental to cosmology, as it spreads across the universe the chemical elements necessary for the formation of rocky planets and for the chemistry of life. Thus, every atom in our body was forged in the heart of distant stars, connecting us to the universe in a profound and fundamental way. Among these systems was our own solar system. About 4.5 billion years ago, a cloud of gas and dust collapsed to form the Sun, and around it, planets began to form, including Earth. Our planet, initially a globe of magma, cooled to form oceans, land, and finally, life. The unique conditions of Earth allowed life not only to emerge but to flourish, leading to a diversity of life forms that cover the planet today. In the chemistry of the primitive oceans and under a carbon-rich atmosphere, the building blocks of life came together, forming the first living cells. This simple, yet extraordinary form of life, would be the precursor to all the biodiversity we know. Throughout the geological eras, life evolved, adapting to every corner of the planet. From the Cambrian explosion, which filled the seas with complex life, to the vast forests of ferns and ferns of the Carboniferous, each geological period brought new forms of life and mass extinctions that shaped the biological diversity of the Earth. When plants colonized the land, they created environments that allowed the development of complex forms of life on land. Dinosaurs, mammals, and finally, humans, all found their place in the terrestrial ecosystem. Human intelligence, the result of millions of years of evolution, allowed us to shape the world around us, building civilizations and seeking to understand the universe that created us. Earth, with its unique conditions, is a testament to the rare combination of factors necessary to sustain life. From its distance from the Sun, which allows the existence of liquid water, to the protection of its magnetic field and the climatic stability provided by its atmosphere. This delicate harmony between geological, hydrological, and atmospheric systems has created the stage for our story, a story not just of humanity, but of all life on Earth. As we explore the cosmos, an intriguing mystery has been revealed. The universe, we have discovered, is expanding. Not only that, but the rate of this expansion is accelerating, a phenomenon driven by a mysterious force that scientists call dark energy. As we contemplate our own solar system, the question arises, are we alone? The search for life beyond Earth has led to the discovery of exoplanets, worlds orbiting other stars. Some of these distant worlds have conditions that could support life as we know it. The human journey through space began with a small satellite, called Sputnik, launched into the skies in 1957. Since then, our insatiable curiosity has led us to unprecedented achievements. We witnessed the first human, Yuri Gagarin, orbit the Earth, and in 1969, Neil Armstrong left the first human footprints on the Moon. One small step for man, a giant leap for mankind, these words echoed around the world, marking the beginning of a new era. But our search did not stop there. Pioneer robots, rovers, and probes have been our eyes and hands in distant worlds. They have landed on comets, orbited Jupiter and Saturn, revealing their secrets, and now explore the surface of Mars, searching for signs of past life and paving the way for future astronauts. The International Space Station, a symbol of international cooperation in space, orbits our planet, a laboratory where we conduct crucial research for future interstellar journeys. Space telescopes, like Hubble and the newly launched James Webb, expand our horizons, capturing the light of the earliest galaxies and unraveling the mysteries of distant stars and exoplanets. Looking to the future, we dream of colonies on Mars, interplanetary travel, and eventually reaching stars beyond our solar system. Space exploration challenges our limits, inspires generations, and reminds us that, together, we can achieve the impossible. We are just at the beginning of our cosmic journey, a journey that connects us more deeply with the universe of which we are a part. Projects like SETI, Search for Extraterrestrial Intelligence, scour the cosmos for signs of advanced civilizations. Although we have not yet found concrete evidence, the vastness of the universe suggests that the possibility of extraterrestrial life is more than mere fantasy. What will be the fate of our universe? Three main scenarios present themselves: an eternal expansion leading to a big freeze, an eventual collapse back into a big crunch, or even a big rip, where the fabric of spacetime is finally torn. The future remains uncertain, but the study of the cosmos continues to reveal clues about our eventual destiny. In our quest to understand the universe, we have discovered not just about the stars and planets, but also about ourselves. Although we are just a small part of a vast cosmos, our ability to contemplate and explore this universe reveals our true greatness. If you marvel at the mysteries of the universe as much as we do, join us on this journey of discovery. Subscribe, share your ideas and questions in the comments below, and let's together explore the wonders of the cosmos.